Here we go with our final exam review, and I'm going to begin with a disclaimer saying that everything on this review is not going to be an exact copy of what your final exam is going to be. What I've done is I've tried to take some of the more difficult topics and help you, remind you what they are about. Here we go. We have a quadratic inequality, and we want to make sure that we have 0 on the right hand side. So I'm going to begin by subtracting x off of each side of the equation. This gives us x squared minus x minus 12 is greater than or equal to 0. I'm then going to factor that into x minus 4 times x plus 3. Now, if this were an equation, our critical values would be positive 4 and negative 3. And on a number line, I'm going to draw this here. Now, we're going to pretend that there's a parabola involved here, y equals x squared, and it would be a parabola opening upward because of the positive x squared. There really isn't a parabola there because there is no y in this. But if there were, we'd be asking where is it at or above the number line? And the answer is at negative 3 and to the left, as well as at positive 4 and to the right. And so our solution set in interval notation would be the set of x values from negative infinity up to negative 3, inclusive of the negative 3, as well as the values greater than or equal to 4. In this next problem, we have compound interest compounded monthly, and so that tells us n is equal to 12. You pretty much need to have memorized the compound interest formula. A is equal to P times 1 plus R over N raised to the NT power. Now we're just going to substitute numbers in. Our principal is $3,600. 1 plus, now 4.5%, moving the decimal 2 places to the left, we're going to have 0.045 divided by monthly, which is 12, raised to the 12 times 5, which is the 60th power. At which point you're just going to directly substitute this into your calculator, round it to the nearest cent, and get $4,506.46. When multiplying matrices, you want to make sure that they are of the same size or order. This first one is 2 rows by 3 columns, and the second one is 2 rows by 2 columns. Since the numbers in the middle don't match, since the number of columns of the first does not match the number of rows of the second, this is not possible. So what I'd like to do instead is amend the problem. Let's just get rid of the last column and multiply the matrices that we see there. Now we have a 2 by 2. The 2's in the middle match, so the 2's on the outside tell us that the product will be a 2 by 2. We identify each position in this matrix. The first one is row 1, column 1. So we will take row 1, the 2 and the 3, and cross it with the 6, negative 1. So 2 times 6 is 12, 3 times negative 1 is negative 3, 12 minus 3 is 9. We then identify the first row, second column. So the 2, 3, we're going to multiply with the negative 8, 3. 2 times negative 8 will be negative 16. 3 times 3 is 9. So negative 16 plus 9 makes negative 7. Down in the bottom left, that's row 2, column 1. So 5, 1 with the 6, negative 1. We're going to have 30 and negative 1, making 29. And row 2, column 2 will be the 5, 1, and the dot product of that, and the negative 8, 3. The 5 times negative 8 makes negative 40. 1 times 3 is 3. Negative 40 plus 3 makes negative 37.